So last time we talked about solving equation with the same base, right? We change them into base of 2, base of 5, right? And then once each side has the same base with one base on each side, then you can drop the base and then just solve for the exponents. So please look over the homework that I returned it to you. The answer key I'll post it later, okay, after the class. And then you can check the steps. Okay, so usually I mark one of you guys and then pick the one that has the least number of mistakes and then use it as answer key. Okay, it has very detailed steps. And if you still have questions why you got it wrong, then you can ask me in any class. So today we're going to jump to page 89. It's still got to do with exponential, okay? But this time we're talking about functions, all right? So please turn to page 89. And can you raise your hand if you are here, right? If you got to the page. Okay, and Jenny, have you found the page yet? Page 89. Yeah, okay, perfect. So function means it can take an input and give an output, okay? So there's input is the X, output is the Y, so that means we can graph, right? Whenever you see function, it means we can plot points. Okay, so that's why you learned about quadratic function, right? Cubic function, and here we're gonna look at exponential function. So the function looks like this, f of x equal to b to the x. So one example is f of x equal to 3 to the x, right? B is the base. So b is the base, x is the exponent. So there are two types of exponential function. One is when the base is greater than 1. Right, this is the first type. So we're going to look at that one first, okay? Base is greater than 1. So you look at the chart at the bottom, base greater than 1. So here I use 2 as an example, right? Our base equal to 2, so it's y equal to 2x. This one, y equal to 2x. So you take an input, right? Use any x and plug it in and find the y value. But I'm going to choose some x value that are negative. So like -2, and then I choose -1, and then 0, and 1, and 2. So you have some points on the left side, some points on the right side as well. Okay, so I would like you to plug it in into the function and then write down the y value. Okay, so for example, for the first one, it will be 2 to the -2x. Okay, sorry, 2 to the -2. So that will give you 1 over 2 squared. Okay, sorry, a little bit lagging here. 1 over 2 squared, which will be 1 over 4. Okay, so our first point is at -2, 1 over 4. So please complete the chart. Okay, raise your hand when you have finished the chart, the table of values. Okay, Eric, we are on page 89. Okay. All right, so let's have Angela share your points. So for x equal to -1, what do you have for y, Angela?
1 over 2.
Yeah, and the next one, 0.
1.
Yeah, and then go on.
2.
Yeah,
And 4.
very good. Okay, very easy to warm up the day, right? Just get the points. So that's plotting the points now. Okay, -2, 1/4. So 1/4, quite small, right? So we can only approximate, right? -2, 1/4. So that's about there. I'm using a red dot. -1 is 1/2 here, right? 0 is 1. 2 will be 4, goes up very fast. Okay, if we do one more, right, 3 should be 8, right? 2 to the 3 should be 8, so it's way higher. So up here. So you can see it rises very fast, right? And if you keep on going to the left, it's just gonna get smaller and smaller, like 1/4, 1/8, right? So it's never gonna reach 0. So therefore, we have an invisible wall. It's like over here. I'm using the green dot, okay? It's like invisible wall that it's never gonna cross. So your graph should look something like this one, right? And then it's approaching the green line, okay? But it will never go to the negative side, right? No matter what exponent you put it in, because the base is positive, so you cannot get a negative number. Okay, so please connect the points and raise your hand once you finish the graph, okay? All right, so if we look at the graph from left to right, okay, looking at the graph from left to right, you can look at it as it's like it's rising up faster, right? As the x value gets bigger, the y gets higher. So this kind of function we say it's increasing. Okay, so whenever the base is bigger than 1, the graph will be increasing. Okay, so that's our first one up there. You can fill that in. B greater than 1, the function is increasing, meaning it gets higher. Okay, so the other one is when the base is between 0 and 1. Okay, we call this between 0 and 1. Okay, it's easier than saying base less than 1, base greater than 0, right? Takes too long. We just say base between 0 and 1. Then we can see that if greater than 1 is increasing, this one should be decreasing, right? The opposite. So let's look at an example. So here I chose a base that's between 0 and 1. Okay, it could be half, could be a third. Okay, anything between 0 and 1, it will be decreasing. So same thing, I'm going to use the same x values. Okay, and then let's plug it in. So our first y value will be 1/2, right? Because our base is now 1/2 to the -2. And remember, we review a negative exponent. It will make it flip, okay? Make the base flip. So the base will become 2, and then the exponent will be positive, okay? When you use the negative exponent, it will become 4, okay? So that's our first y values. Please complete the table, okay? This time I'll let you carry all the way to graphs, okay? Once you finish the table and the graph, you can raise your hand. Okay, please raise your hand when you have finished the graphs. Kellen, can I get your table of values for -1? What do you have?
I got 2
Yeah.
for 0, 1,
Yeah.
1/2,
Mm-hmm.
2, 1/4.
Very good. Okay, thank you. So let's plot the points quickly. -2 goes up to 4. -1, 2, 0, 1, 1.5. Right, so you can see it's like reversed, right? Flipped. Okay, so same thing. It also has an invisible wall or invisible line on the x-axis. Okay, that the graph is approaching to, right? So go something like this way, curving. As we go from left to right, it's getting smaller, right? So dropping down. Okay, if you look at the arrow, okay, looking from left to right. Okay, please raise your hand if you finish the graph. So this one is for decreasing. So please remember, you look at the base, right away you will know whether the graph should be increasing or decreasing. All right, so another way to look at this function, okay, this one is base is 1/2, right? Half to the x is I can change the 1/2 and write it as 2 to the -1, right? So I can write it as y equal to 2 to the -x. They are the same. I just write it differently, right? 1/2 is the same as 2 to the -1, and -1 times x give you -x. So if you look at this one in the green box, okay, and compare with the one on the left side, the one I'm highlighting with the yellow, right? Compare those two yellow highlighted. The equation only has an extra negative, right? Differed by an extra negative. So when you have a negative on the x, if you remember from transformation, negative on the x, what does it mean on the story? Like, how does it change the function? Does anyone remember? If you have negative added to the x.
Jason,
Yes, Daniel?
I think it's reflection over y-axis.
Very good. Okay, so negative with the x reflect over y-axis. Okay, this is a sort of connection to our first chapter. Okay, reflect over y-axis. So if you look at a graph, right, the graph on the left, the graph on the right, is a flipping right over the y-axis like a mirror. Right, so that's another way to look at the same function, right? Instead of decreasing, right, you can think of it like a reflection. All right, now let's fill in some terms. Okay, remember I told you the graph is approaching the invisible line, the green line. That line is called the asymptote. Asymptote line, right over here. So if it's on the y-axis, all the points on the, it's on the x-axis. Okay, the asymptote line is the green line. It's the x-axis. Any point you pick on there, the y has to be 0. Right? So we call this equation y equal to 0. If the asymptote line is higher, right? For example, if it goes here, right? If it's this line, then this is called y equal to 3, right? Because every point on that line has y value of 3, okay? But the one we have here is y equal to 0, okay? Let me erase that first. Okay, so we have an equation y equal to 0. Let me write it down. Okay, same with the left side. So it doesn't matter increasing, decreasing, they both share the same asymptote. A domain is the x value. So since we can use any kind of exponents, right? I could use negative numbers, or I could use 0, I could use positive numbers. So for domain is all real numbers. Okay, what about the range? Evan, what do you think the range is for these two graphs?
I'm not quite sure.
You look at the graph, look at the red line. The y value, range means the y value. Is the y value any numbers we like any and everywhere, or is there a limit? Yeah, Eric,
Doesn't go below 0.
can you go below 0?
No, like it doesn't go below 0.
Yeah, has to be go above 0, right?
Yeah.
Okay, so it has to be higher than the the y equal to 0, the asymptote line. So Evan, how do you describe that then? All the graph has to be higher than y equal to 0. So you would say y is what?
Is it just y is greater than 0?
Yeah, that's it. Okay, so range has to do with the asymptote line. Because asymptote line is the line that stops, well, kind of not really stopping, is like limiting where the graph can go, right? The whole graph has to stay above the asymptote. That's why it's greater than 0. Okay, these can change. Okay, later we're gonna add things in. Okay, make the graph move, make the graph flip, right? So of course the range will change as well. Okay, these are just basic examples. Okay, and then the x-intercept. Okay, Marcus, where do you think the x-intercept is?
Isn't it? Wait. Isn't it? Isn't it 6?
What does x-intercept mean?
Where it hits the x-intercept?
Where the graph hits the x-axis.
Okay, so
Does the graph touch the x-axis?
yeah.
Where does it touch it? Can you show it on the graph? Let's say we use the left one.
Isn't it 0, 1?
0, 1. So you mean like let me circle it.
Oh wait, no, that's not. Sorry.
0, 1 is here.
Yeah.
That's y-axis, right?
Yeah.
Where does it hit the x-axis?
Wouldn't it be like here?
Where? Okay, well, this keeps on going. That's an arrow, right? So it actually keeps on going, but never touches. Okay, remember I said this graph has an asymptote line.
Oh yeah.
So it doesn't touch the x-axis. So this is a trick question, okay? It has no x-intercept, right? None. Right? It just gets smaller and smaller, the value for the y, it gets smaller, but it will never reach 0, right? If you look at the table, it will be 1/4, next one will be 1/8, next one will be 1/16, right? It gets really tiny, but it can never become 0 because the base is 2, right? So it's always gonna be a value there, no matter what exponent you put in. So y-intercept will be the 0, 1. Okay, so we'll say the y-intercept is at 1. Okay, so this is the y-intercept. right? Does anyone have question about these two graphs? These are the basic ones, okay? So you need to know these two very well before we look at the other examples. Okay, so can you please raise your hand if you're ready to move on to the practice?
So for the y-intercept, it's always 1?
Yes, yeah, because when it doesn't matter what base you use, right? If the exponent is 0, it will always be 1. Make sense?
Yep.
Okay. So it's from one of the exponent rule, right? Exponent equal to 0, the whole thing just turns to 1. Okay, Nick and Eric, have you got down everything? All right, so let's move on to, we're going to next page and look at other graphs. Let me clear the drawing first. Okay. All right, so over here, it wants you to sketch, okay? So meaning you don't need table, okay? What I'm looking for is when you're just sketching, I need to see the asymptote line. That's very important, right? And then I also need to see the where is the original 0, 1, right? Because 0, 1 is like sort of like the same point for every basic ones, but it will move, okay? If you don't understand what I mean right now, after I show you the first example, you'll understand. Okay, so I need to see those two. And then of course, you show the curve. Okay, so you just need to show these 3 things when you're sketching the graph. You don't need a full 5 points table value. Okay, do not use tables. And then once you get a sketch, we're gonna answer these things: domain, range, equation of the asymptote, y-intercept. Okay, so total of 4 things. 1, 2, 3, 4. Okay, so I'm going to start with the first one. So if you look at this example, right, instead of just y equal to 3 to the x, it has x plus 2, right? It has a minus 4 at the end. So we can sort of ignore that for now, right? Those are all the added on, the extra ingredients, right? If we take those away, we can see that it has to do with 3 to the x. So we have a base of 3. So will that be increasing or decreasing, Susan? If you have a base of 3,
Increasing.
increasing, very good. Okay, so first thing you need to do is to identify, okay, whether the graph is increasing or decreasing. So we are gonna write that out as well. So you can write it as compare to y equal to 3 to the x. So we know, right, just a little sketch is increasing, right? At least we know it's the shape, okay? And then we are going to add things in. So you can box that, right, and compare with this one. So you know the way it curves, it should look like that. Now, if we take away all the covered up, right, x plus 2 and then the minus 4, we can change that into, because the minus 4 can be moved, right, into move it to the y side. So now you can apply what you learned in transformation. right? Whatever that's movable to the y side, it affects the y. Whatever that move like stays with the x, it will affect the x values. So if it's x plus 2, does anyone remember what does that mean in the transformation? We have that reflection, right? What else? S for stretching, right? Shrinking. T for translation. So if it's x plus 2, what does it do? Chris?
Pardon?
What does x plus 2 tell you about the transformation? Is it a reflection, or is it about stretching, or is it about
It's, I can hear the last thing you said.
is it about translation? We have the RST. Do you remember that?
Yes, I think it's translate down 4.
Down 4, and what else? What about the x plus 2?
Let's translate down 2.
Okay, so it has to do with x. X has to be left and right.
Oh, is it translate right by 2?
Okay, so it should be left by 2.
Okay.
Okay, no problem. So it's our first chapter, okay? Good chance to review, right? So if you see a y plus 4, it means down 4. Okay, if you have forgotten that, please write this down, right? If it's x plus 2, x is either left or right. But if it's plus 2, it means it will go left. 2. Okay, so you can use the transformation idea. That's why you don't need the table of values. Okay, because if you use the table of value, you don't know where the center is. You might be only drawing the far end of the graph. Okay, you don't get the main part. Right, so once we got the story, we can get our points. Okay, so next we're gonna our original key point is 0, 1. That point never changed, right? If you look at the previous page, the y-intercept for either graph, whether decreasing or increasing, it's always at 1. So we use that like a key point, and then we will apply the translation, right? Moving left and moving down. So 0, 1 will move to a new place. Where is the new place now? Daniel?
I think it's -2, -3.
Yes, very good. Okay, so you minus 2 to the 0, -2, and then -4, right? 1 minus 4 give you -3. So that's the point I want to see, right? I want to show on the graph. Next thing is the intercept. Sorry, the asymptote. We have a y equal to 0 as our asymptote before, right? And then now we do the transformation. The thing that will affect the asymptote is the one that affects the y, right? Because y equal to 0, that's the y value, right? So we have to move it down by 4. So our new asymptote will go to y equal -4. Okay, so moving left to by 2, it doesn't affect the asymptote. Okay. So we got our 2 things, right? We have the asymptote there, we have our new point, and we put them in and draw the curve. So let's start with drawing the asymptote line. It's at y equal to -4. We draw a scale here, right? dashed line. So this is our y equal to -4. And then we have our point, -2, -3. Okay. Everyone got the point and asymptote yet? And then we are going to draw the graph, okay? So if we draw the curve now, right, we know it's increasing, right? So it should go something like that. But we can see that it will cross the y-axis. So before we actually draw the line, I want to also figure out where the y-intercept is, okay? So at the bottom, I'm gonna just leave a space for the domain, leave a space for the range. Asymptote, we got it, right? Y equal to -4. Y-intercept. Okay, to find the y-intercept, we need to make x equal to 0. So we plug it into our function. Y equal to 3 to the 0 plus 2 minus 4. Okay, can you please calculate this value? Okay, raise your hand if you got that. Our y-intercept. Okay, plug in x equal to 0. Okay, do you know what to do right now? Okay, plug in 0 into the x so that we can find the y-intercept. Okay, Waylon, what do you have for the y-intercept?
I got 5.
Very good. Okay, so 3 squared is 9, right? 9 minus 4, it give you 5. So we have our y-intercept is at 0, 5. Okay, so we can plot that in. 1, 2, 3, 4, 5. We know it has to go through there. And the graph is increasing. So make the curve bend so that it crosses the y-intercept as well. Okay, so on the homework, right, what you need to show for the sketch are the 3 things here. Okay, first one is the special point, right? I put a star there, and then the asymptote line, the green line, you need to show that as well, and the curve. And if there's a y-intercept, right, you need to find it too. Okay, so it curved the right way. Otherwise, you can curve many ways, right? You can make a curve and go this way. That's also increasing, right? You can also make a curve this way, right? But there's only one graph that can curve increasing and go through the same y-intercept. Okay, so I'll let you guys write these down, draw the graph. Okay, please raise your hand when you finish domain and range. I'll let you guys also do domain range. Okay, so everything in this yellow. Okay, so please complete that and raise your hand. This is our first question. That's why we spend a lot of time. Okay, as you do more, should be faster. Okay, please raise your hand. You already, if you found the domain range. Domain is always the same, okay? But range will change because now the graph is at a different place. So this curve, it has the same curvature as y equal to 3 to the x. It's just every point has been moved left and moved down, okay? Move to a new location. Right, we should got the domain range by now, okay? Domain range is not too difficult. Okay, Nick, what's the domain?
X is equal to, X is greater than or equal to -4.
We're talking about domain. Domain is x, right? The -4 has to do with the y.
Oh,
Okay, so -4, you use that for the range. So what do you think the domain is?
is it like X is,
You think about the left and right, okay?
oh wait, no. X is equal to all real numbers, right?
Right, yeah. So for when you are talking about domain, you think about x values, and x value is either going to the left or going to the right. So since the graph, right, it points to the left forever, never stop, and then it also extend to the right side forever. I keep rising to the right, so never stopping as well. So all real number. Okay, CZ, what's the range? Claire, what do you have for the range? Oh, Caesar, are you there?
Oh, sorry. The range is y is greater than -4.
Very good. Okay, y greater than -4. Okay, so when you're talking about the range, you look at the asymptote. Okay, y equal to -4. So it has to do with the y value. Okay, please raise your hand if you're ready to look at question B. So if you look at question B now, what do we need to compare with, right? For the last one, we compare with y equal to 3 to the x, right? What about anybody? Lily, what do you think? We should compare with y equal to what?
Y equal to -4 to the power of -x.
Okay, if we take away even more, make it more simpler, take away the -1, right? Let's take away the negative, take away all the negative. Then it's just a simple y equal 4 to the x. Okay, all the other things are decorations. We just add it on and make it change. Okay, because when you want to compare, you want to either compare with the increasing one or the decreasing one. Okay, so you can see these two basic ones, the base has to be positive, right? It's either greater than 1 or between 0 and 1. So there's no negative at all. Okay, so when you want to compare, you want to compare the most basic form. Okay, to compare with that one. Take away all the extra things. So y equal to 4 to the x, is that increasing or decreasing? Callum, is that increasing or decreasing?
Oh, it should be increasing.
Yes, okay. Base of 4 is once again increasing. So the shape is that again. Now we need to add things in, right? Change it to story form first. Okay, so what will the story form look like? Okay, I'll let you guys try it. Anything that's movable to the y side, please move it over. Anything stays with the x, then keep it there. Okay, so raise your hand once you have the story form. Okay, does anyone have question about which ones to move to the y side? Nick, how are you doing? Did you change it to story form yet? Which parts are movable to the y side?
Like could you move forward to the x, like to the exponent?
4 to the negative x. That one has to stay there.
Well, then like then you can't move anything, right?
Yes, you can. There are actually two things you can move here.
Oh wait, the +1 and the negative.
Yes, okay. So after you move, what does it look like on the left side?
So So would it be like negative y minus 1 is equal to 4 to the negative x?
Okay, so the x part is okay. If you want to move things to the left, you move the -1 first. So it become y plus 1.
Yes.
Okay, and then how do you move the negative to the left?
So multiply both sides by -1.
Yeah, okay. Or you can do dividing. I'll do dividing instead. Okay, so it's the whole thing divided by -1. Okay.
Mhm.
Yeah. So that's a story form we want to get. Okay, separate the x part and the y part. So each of them tells you different things. Okay, we start with the negative. This -1 and this -1 tells you different things. Okay, let's put it this way, right? The same way we learned before. We'll write down the RST. So just like last time, right? Last page, if we have a negative with the x, right? I think it was Daniel answered this, right? Negative with the x reflect over y-axis. So once again, we have a negative on the x, right? So we have reflect over y-axis. And not only that, we also have a reflection over x-axis because you have a negative underneath the y, right? And x-axis. So it got reflected twice. For s, you need to have a number that's other than 1 underneath the variable. Here, there's no stretching or shrinking, okay? No expanding or compressing. This is none. Usually question like these, they don't give you too difficult, okay? Just need to know how to identify reflection, okay, and translation. Okay, what's the translation here? Evan, what do you think the translation we got here?
Uh,
Yeah, did you say something, Evan?
sorry, I'm thinking right now. Sorry.
You can look at the example we have on the last one, right? Question A, we had a translation of moving left 2, down 4. What about this one?
Would you move down 1?
Very good. Yeah, we have a y plus 1. That tells you it's down 1. Okay, for the left and right, there's nothing, okay? Because you only have a negative multiplying with the x. That's reflection, okay? That's not translation. Right, and before you start plotting things in, okay, we need to have a point, okay? 0, 1, we need to get the new location. The asymptote, we also need to get a new one, okay? So same thing like before. Please find their new place. Okay, can you raise your hand if you got the new point and the new asymptote? Okay, Eric, do you have the new point? Eric, are you there?
No.
Do you know how to find a new point for 0, 1?
It would be x is equal to 0, right?
Yeah, x will be 0.
And then negative is -2.
-2. Yeah,
Yeah.
that's right. How do you get -2? Can you tell us?
Because the x power only applies to the 4. So it's just 1, but then there's negative, so it's -1 minus 1.
Okay, very good. So we'll do it slowly. Okay, if you are confused on what to do to get a new point, you look at the story form. Let me circle that. Okay, here. Okay, we have, for example, if you want to get the x values, you look at the x part. You have a negative times x. So that means your x value, you need to times it by negative. So 0 times negative is still gonna stay 0. Okay, so the x value doesn't change at all. Okay, now if you look at the y side, this part, it has a -1, right? That means it's reflected over the x-axis. So all the y value need to times by negative. So 1 times negative give you -1. And then move it down, right? Because y plus 1 means you move down 1. So -1, you subtract 1. So that will give you -2. Okay, so first it will change it to 0, -1, and then change it to 0, -2. Okay, so it has two things happening: a reflection on both x and y, and then moving down. Okay, what about the asymptotes? How do we get the new asymptotes? Susan, you want to give it a try? What do you have for the new asymptote?
Do we plug 0 into x?
0 into x, that's for finding y-intercept. Right, y-intercept means x has to be 0. Okay, so we don't use any numbers to put it in. For asymptotes, you think about the stories, the RST. Which one of the RST affects the asymptote, the y equal to 0?
The transformation?
Transformation is for the whole thing. RST is called transformation. Are you talking about translation?
Yes.
Okay, so what does it do?
The y goes down by 1.
Yeah, so it will become, used to be y equal to 0, right? Where,
-1?
yeah, it will become y equal to -1. Okay, so that's a new asymptote line. If you do reflection on the asymptote line, right? Think about if I draw a line, okay, anywhere. Let's say this green line is the asymptote line. If I flip this over the y-axis, it still stays there because it's horizontal, okay? If there's a reflection over the x-axis, then it'll flip up to the top, okay? But since our original asymptote line is at the center, right on the x-axis. So no matter what reflection you do, right, flipping left and right, flipping upside down is still gonna stay at the same place. Okay, so reflection does nothing to the asymptote line, okay, for this one. So it looks like we are ready to graph, okay? Anyone has questions? All right, so I'll let you guys graph, okay? Show the point, show the asymptote line, and the curve. The curve will be a little bit tricky because we have reflection, so you got to consider that as well, because that will affect which way it will curve. Okay, I'll let you try that first. So once you have a rough sketch, please raise your hand and we'll check your sketch. Okay, let's draw the point first. 0, -2. A point there, 0, -2. Y equals to -1. So that means asymptote line is here. This is y equal to -1. So where does it curve? Okay, the y-intercept is just happen to be 0, -1. Okay, so we got it. There's no new place. Okay, please draw the curve and raise your hand. Which way would it curve? Basically, there are 4 options, right? So you can curve something like that, right? Curve something like that, right? Curve this way, right? Curve this way. 4 different ways, right? Okay, please raise your hand if you finish the sketch. Think about the basic one, okay? The basic means the one in the red box. Okay, that's where you start. And then think about how each of the RST will affect that basic. Okay, so you have to think about, if I flip that over y-axis, what does it look like? If I reflect that over x-axis, what does it look like after that? And then I need to move it down. right, by 1, where would it go? Okay, just going in the order of RST. Still only 3 people got the sketch. Angela, do you have the sketch?
Not yet.
Okay, let me know when you have it. Remember, you don't need 5 points, okay? No table values, just use the basic and then do flipping. Okay, Jenny, no problem. Don't have it yet, Angela?
I'm not really sure how to do it.
What do you have so far?
Do you like reflect it on the graph, or is it already like reflected?
If you look at the one in the red box, okay, that one is the basic without any negative, right?
Yeah.
Yeah, so you just flip that one, okay? Flip that over y-axis, flip that over, and then continue flipping over x-axis. They want to see the curve after the 2 flipping. So let me know what it looks like. You can draw on the screen, okay? Kind of like a comic strip, okay? Okay, Angela, how about you try one by one over here? Angela, you there?
Should I do the y-axis or the x first?
Okay, so you look at the top right corner, right? Do you see I wrote down y equal 4 to the negative x? Do you see that?
Yeah. Yeah.
Okay, that one is flipping over which axis? Which one?
Nothing. None of them, isn't it? Like
What? Sorry, I didn't catch you.
the in the red box, right?
Let me highlight that. Okay, I'm talking about this one. Y equals to 4 to the negative x. What's the reflection for that?
Over the over the x-axis.
Should be y-axis. If the negative is beside the x, should be reflect over y-axis. Okay?
Yeah.
Okay, so what does the graph look like after reflect over y-axis? Can you draw it in the small axis there? Yeah, very good. Okay, so instead of increasing, now it'll be decreasing. Now, if we continue, okay, continue from there. So look at the one at the bottom, right below that. You have an extra negative in front. That's telling you we have a reflection again, right?
Yeah.
So reflect over.
The x-axis.
Yes. So this time you need to continue flip that over x-axis. Well, so what does it look like then? That's right. Okay. And then there's no stretching, right? So we're gonna move the same graph, move it down by 1. Then that will be the final graph we want to draw. Okay.
Yeah.
So can you put it into the big box now, the final product? And it has to go through that special point, 0, -2.
Wait, sorry, does it not pass 0, -2?
Well, it has to pass through 0, -2.
Oh. Wait,
That's why I call that a special point, right? It have to show that. Yeah, there you go. Okay, so that's the graph we want to draw. Okay, when you're sketching, you go in steps. Okay, follow the story. So you start with a reflection, right? You can go in different order for reflection, doesn't matter. Okay, and then reflect, right? So for both of them, the asymptote did not change. It still stays on the x-axis. And then the whole thing moves down, including the asymptote line. So that's why the green line now shifted down by 1. Used to be at y equal to 0, it becomes y equal to -1. And the special point, if you look at the special point, used to be 0, 1. After reflection, it's still 0, 1. But reflect over the x-axis becomes 0, -1. And then you move it down, becomes 0, -2. Okay, so that's the final graph. Okay, can you raise your hand if you understand how we get a sketch here? So you can see the transformation, very important, right? What you learned in the first chapter, RST, we applied it to the trigonometry graphs, right? Also applied it here in exponential graph. Right, so please complete domain range, asymptote, y-intercept, okay? So raise your hand if you got everything in the yellow box. Asymptote, we already have it, right? Y asymptote is y equal to -1. Domain, range, y-intercept. Okay, Caleb, what's the domain range?
Domain should be every real number,
That's right.
and then y should be greater than or equal to -1.
No. Now look at the graph. Is the graph above or below the?
Sorry, it should be lesser than or equal to -1.
Can they touch the green line?
Yes.
It won't touch. That's why it's called the asymptote. It will get closer and closer to the green line. It never touches. So to be just less than. Okay, it won't equal to. All right. So only less than -1. If equals to -1, that means it will touch the asymptote line. Okay, y-intercept. Lily, do you have the y-intercept?
Is it just 0 and -2?
Yeah. Okay, so this just happened to be the same as our special point. Okay, if it's not the same, right? If it's something else, then you need to do what we did before, like question A. You plug in x equal to 0 to find it. Okay, so these two they are both starting with the increasing, right? Because you have base of 3, base of 4. Let's look at one more example that is decreasing, right? You have a base of 1/4. And then instead of just simply x, right? If you compare with the other two examples we just did, right? First one we have x plus 2. Second one we have -x. Okay, question C, you have 1 minus x. So this time, let's see how far you guys can work on your own. So compare with something. Okay, so think about what do we compare with. All right, and then change that into story form. Okay, you can see the drill again. Okay, and then write down the RST. And then we get a new point. And then we get a new asymptotes. Right, so let's figure all these out first. This one we need to compare with the base of 1/4. Okay, we take away all the extra things. The +3, the 1 minus, right? Make it look simple. Okay, so we'll go over when you have all the RST. Okay, we'll make sure your stories are straight. So please raise your hand after you found out your RST. Okay, Marcus, is this graph increasing or decreasing?
Decreasing.
Yep, very good. Okay. So the one you're comparing with, the one you're starting with, it should be decreasing. Maybe at the end it will be something else, but you have to start with the correct one. Okay, you can raise your hand if you found out RST, okay? All right, let's check the story form first. So what will be on the Y side, on the left side? Which ones are movable to the Y side? Chris, what do you have on the left?
-3.
So what do I write?
Y equals y minus 3.
Yeah, Y minus 3. Okay, do you have any change on the X part?
No.
Okay, for the story form, the variable has to be at the front, but in the question we have 1 minus X. How can we fix it so then the X is at the front?
X minus 1.
Is 1 minus X same as X minus 1?
Well, can you move the X around and you can divide it by 1, right? -1, right?
Yes, yeah. So can we, so what will be the final look like? Move forward. Or you want to show me the steps, how you moved?
Just move the X and the 1 around so it became -X plus 1.
Okay, negative X plus 1, and then?
I divided everything by -1.
So it becomes
X -X X minus 1 over 1.
over
-1.
-1. Yeah, you divide everything by -1. So they are all the same, okay, just written in different form, okay? You have X minus 1 over -1. So you can see there's a reflection here, right? And then there's a translation too. Right, so this story form, very important, okay? How to get it right, how to put it in the right form. Okay, if you have the RST, please raise your hand. Anyone else finished? RST. Okay, Marcus, do we have reflection here?
Isn't it over the y and the x?
Why do you think it's over y and x?
Isn't y, oh wait, are they negative? Oh wait, no reflection, isn't it?
Is there a negative with, is the negative with the x or with the y?
Both.
Where do you see that?
Y minus 3x minus 1.
That's a plus and minus. Okay, x minus 1, y minus 3, that's not the reflection. You want to look for anything that's underneath.
Oh wait, minus 1 for x.
Yeah, so negative, right? Divided by -1 or multiplied by -1, not add and subtract, okay? So you have negative with the x. What kind of reflection we got?
Isn't that over the y-axis?
Yeah, over y-axis. Okay, so if you find that you have trouble with the reflection, that means you need to go back and take a look at more examples in chapter 1. Okay, review transformation. Okay, how to tell reflections from your story form. Okay, stretching, shrinking, we have none. Okay. Angela, translation.
Up by 3 and right by 1.
Yeah, up 3, right 1. Okay, please raise your hand if you finish all the RST. Now we need to get a new point and a new asymptote. All right, please raise your hand again if you have the new special point and the asymptote line, asymptote equation. Is there anyone having trouble getting new points? I forgot how to use story form to get new points.
Jason, could you go over how we can get the new points?
Oh, thanks for asking. Okay, so Susan, what you need to do is to look at the form. Okay, and then for example, if you want to figure out the x values, then you look at the x part. Let me circle it. So what do you think in the x part? Or what do you see there?
X minus 1 over -1.
Yes, okay, so the x value, you just multiply by the bottom number, and then the x minus 1 tells you to move to the right. So you need to add it by 1. Okay, so your x needs to times -1 from the bottom, right? From the bottom number, and then add 1. Let me write it down, okay? So your formula will look like this. Okay, I'll write it here. Negative x, right? All the x times negative and add a 1. Does that make sense so far?
Mm-hmm.
Okay, now you do the same thing for the y part, okay? For the y side, what do you see?
Y minus 3.
And what does that mean?
You go up 3.
Yeah, so if you go up 3, do you add or subtract the y value?
You add.
Yeah, so it'll be y plus 3. Okay, because there's no number underneath the y, so nothing to multiply. Okay,
Okay.
yeah, you understand what to do now?
Yes, thank
Okay.
you.
Yeah. Yeah, all these are from transformation. Okay, so I totally understand that if you have forgotten how to do that, but you need to let me know, right? So I can help you. Because yeah. So far only 3 people got the point. Okay, please raise your hand if you have the new point. Okay, so Nick, where are the new x and y?
Is it -1 and +3?
-1 and positive. What did you do?
I'm not sure.
Did you hear what I when I explained the formula down here? Do you see
Wait,
it
could
highlighted?
you re-explain it?
So the negative x plus 1. Do you see that? I wrote negative x plus 1.
Yeah.
Okay, so that negative x means you take the -1 from the story form. You see I highlighted?
Yeah.
Okay, that's a reflection over the y-axis. Okay, so all the x value needs to times -1. So that's why you have negative x. Okay.
Okay.
And then the x minus 1 from the story form on the numerator, that means moving to which side?
Moving to left side.
To the right by 1, right? Translation.
Oh, okay.
Okay, x minus 1 means you move it to the right. So if you want to move it to the right, then you need to plus 1. So that's why it's negative x plus 1. Understand?
Okay, yeah.
Okay, and then now for the y minus 3 in the story form, y minus 3, what does that mean?
Up 3.
Yeah. So if you want to move the points up 3, you would add it by 3. So y plus 3. Okay?
Oh, okay.
So you take your original point, which is 0, 1. You plug it into those two formula. The x, you times by negative and add 1. The y, you add it by 3. Okay?
Okay.
So can you tell me the final place then?
So would it be 1 4?
Yeah, so go to 1, 4. Okay, so you get everything here from the story form. Okay, y minus 3 means you need to add 3. x minus 1 over -1 means times -x and +1. Okay, so if the story change, the things that you need to do will change as well. Okay, asymptote line. Where is the new asymptote? Angela?
Y equals 3.
Yes, okay. How did you get that? Can you tell us?
It's up. It's circle.
What? Which part?
The y minus. I'm not really sure.
How do you know it becomes y equals 3? What did you do?
It was like it's the number in the equation.
Which number?
3.
The y minus 3, right?
Yeah.
What does y minus 3 mean? What does it do to the graph if it's y minus 3?
It moves it up by 3.
That's right, okay? So all the y value, you need to add 3. Okay, moving up means you add 3 to it. Okay. Is it very confusing right now or it's okay? Y equal to 3, that's plotted line, okay? That's up here. And then 1, 4. 1, 4 is right here. 1 and 1, 2, 3, 4. So this point. Okay, so now we need to know where does it curve? How does it curve? It started with decreasing, right? But then there's a reflection. Okay, so where does it curve now? Okay, so please raise your hand if you finish the sketch. Okay, how do you draw the curve? Okay, Caleb, can you show on the screen how do you draw the graph? Going through 1, 4. Okay, so it got flipped over, right? Reflected over y-axis. Very good. Okay, if I reflect over y-axis, used to be decreasing, should now become increasing. Okay, so the curve will go something like that. All right, so let's go over the domain range. Domain, as always, is all real number. What is the range for this? Waylon? What's the range? Look at the graph. What do you say the y?
Is y great? No, the range y is greater than 3.
Yeah, very good. Everything is above the green line. The green line is at 3, so greater than 3. Asymptote line, we already found it, y equal to 3. Y-intercept, okay, y-intercept looks like we need to calculate that. And by the look of it, right, the y-intercept is somewhere between 3 and 4. Okay, so to find the y-intercept, Lily, how do we find y-intercept? What do we need to do?
Plug in 0 for the x.
That's right. Okay, so let's plug it in 0 into the x. And we'll find out what that equals. Okay, so y equals to 1/4, 1 minus 0 plus 3. Okay, and Eric, can you tell us what you get?
3 1/4.
3 1/4, that's right. Okay, so 3.25. So at 0, 3 1/4. So from our graph, it's a little bit too high, right? I'm putting at, so to make it more correct, we need to bend it a little bit more, right? 3 1/4, probably somewhere there, right? So I need to make it lower, closer, and then bend up. Okay, so that should be enough practice for getting the sketch. Okay, so remember, you don't need to show 5 points for table value. All I'm looking for is the special point, the asymptote, and the correct way you curve it. Okay, sometimes the curving it got changed by the reflection. Even though you started with a decreasing, but after reflection, it will be increasing, right? Sometimes it's above the asymptote line, but after reflection, it becomes under the asymptote, right? So you have all kinds of examples here. So we'll have a break and then we'll start again at 11:35, okay? 11:35. If you have questions about these graphs, you can ask me.